keep I'm just going to keep the slides minimized because I won't be able to switch back and forth. This is a little bit of an introduction, so I'll be kind of going through the code side as well as on the console side. I'll be looking off to the screen just because the big monitor is much easier to handle. So, what we're going to be covering today is the Elastic Container Service. That's one of the container orchestration services available at AWS. And let's just jump into it. So first of all, just to kind of give an introduction, a lot of you would have already been working with Docker and are familiar with containerization. So this ECS is essentially a container orchestrator where it handles the individual containers and then basically provides you services so that it can deploy your containerized applications onto the cloud, onto your own infrastructure or onto serverless infrastructure provided by Amazon. So these are the layers that are in like a typical setup. You basically have the container definition that right at the core is your Docker file, and they even have support for Docker Compose now. And then you have the task definition. It's essentially a wrapper around your Docker file. So you inside a task, inside an ECS task, you can actually have multiple Docker containers. Kind of like a common setup would be if you have your code container, which has all of the PHP code or Node.js code, and then you have a separate container, say for Nginx, so that acts as the server. And because they're inside the same task, they basically can communicate with each other very easily. And then outside of that, you have the service, which is kind of like the essentially, if you use something like supervisor on Linux or any kind of service that makes sure that something else is running all the time, it's something like that. And we'll kind of get into the deeper in a little bit. And then you have the cluster. And the cluster is essentially the full set of servers and other resources that are the collection of your infrastructure. You have many services and many tasks inside a cluster, and then a cluster is generally locked to one region in AWS, but across multiple availability zones. Going into things a little deeper, hopefully you should be able to see this a little clearer. I'll just maximize it here. So yeah, I'm just going to get rid of this. So here what you have is your container image, which is usually Docker. It's hosted on Docker Hub or even an external registry or something called ECR, which is Elastic Container Registry, which is Amazon's own providing. Your tasks essentially pull these images, build them, and then you have the containerized task container inside the AWS task. The tasks are then deployed onto either Fargate instances, which is Amazon's serverless provider, or you can also deploy it onto your own infrastructure or EC2 instances where you buy capacity and you deploy onto those servers. And then the service makes sure that, if you have defined, let's say you want 3 instances of an application running at all times, just to make sure that it can handle the load, the services make sure that those instances are up. If something goes down, it basically makes sure that there are replacement services, replacement tasks coming up to take them, and then also can automatically adjust according to the load that you're seeing right now. And then on the outside, CloudWatch provides telemetry and monitoring so that you know at any given moment what is going on inside these things. Because the problem with things like serverless is that you don't have a server where you can just SSH in. It's not possible because these are servers that are running behind everything and you don't really have access to those things. So then CloudWatch allows you to look at things like memory utilization and CPU utilization and make sure things are okay. And also things like logs and other metrics and alerting. So we're just going to go into a quick tutorial because it's a much easier concept to talk about if you're just jumping in. if you do have any questions, just kind of, ask at that point itself, I would say, because it's much easier to go ahead during and kind of answer them during the presentation. So before we start, you obviously need an AWS account. These are generally not going to cost you too much to sign up for, because you just need a credit card. But I generally tend to sign up with something like FreeMe, so that for whatever reason, if I forget to shut something off and a malicious entity gets access to these end URLs or endpoints, I'm not gonna wake up to a giant bill. So it's always a good idea to keep some kind of backup there and have some kind of billing alert or something set up. You'll also need the AWS CLI installed. There's a couple of commands you should be able to set that up easy. And then of course, Docker and Node. This is just for this example because I just wrote like a very quick, tiny program to just show you how things will work. I'm just gonna show the code here. So essentially what we have is we have an Alpine node image. We have the application and we just copy it over and then do an npm install on the Docker side. And on the compose side, we have the same thing. We just make sure that port 3000 is open, and we just set the command up. It's very simple here. And the application itself is 20-30 lines. All it does is it has a help endpoint which returns okay, and the regular URL, if you hit it, will just run a counter and make sure that it exits at 5 requests. This is useful for later on, and it's running on Express. So just do like a quick demo of this. Okay, app is running on there, and we just so what's important here to note is that it basically only has 5 requests and then it will kill itself. So this is important later because we're going to check something called self-healing on the AWS side. So this is the code, very simple, very quick and dirty. And then that's the Docker stuff. And then we basically now get into the meaty part on the AWS side. So the first thing that we need to do is create a repository instance on AWS so that we can store the Docker build images on ECR. How you do that is you just go into services on AWS and then go into the registry. I've already created one for our example here because usually this only takes, like the whole process would only take maybe about 30-40 minutes, but to save time, I have everything set up on my end. But generally what you want to do here is just give it a name, decide that it's going to be public or private. In our cases, we'll just go with private. And that's pretty much it. Like things like tag immutability and scan on push, these are not really setting to change right now until you understand them well. And it's pretty easy, and then you create it. And then what you basically get is a repository with where you can start to push images. And even here, you don't really need to do anything. Just look at the view push commands. And you have 4 commands here. Very simple again. What this does is it authenticates your authenticates Docker with your AWS credentials so that AWS can push the built image to ECR. And then you do a build. This is again fairly simple. And then once you have the Docker image, you just tag it with the repository information that you created. Again, all the commands are just auto-generated for you. So all you need to do is copy paste this and it's done. And then the final step is you just push it. So once you do push it, so by default, it tags it as latest. And then once you do push it, everything just goes through. So we just do that right now. Just copy paste. So right now I'm logging in and then I should, login succeeded. So that's fine. We'll do a Docker, do a build here right now. You can see the font and everything, right? It's not too small. It's the terminal, so it should be okay, I think. So now we've finished building it. Then you tag it. You can tag it with whatever you want here, but generally there's a couple of ways that you do this. You tag it with latest, and then you also tag it with a certain version number. In our case, we don't really care too much about the version numbers. So just gonna see. So I won't be running it right now because I ran it directly, so it won't be showing up here, but I'm just going to push the tagged image. So here, what happens is, since I've already pushed the image, it basically looks at all of the layers that are existing, and since they all exist right now, there's really no change. You basically note it with the SHA hash here. So now the image that we want to work with, the Docker built image, is inside here. The size is about 42 MB, and now we can use this via the URL here, and we can basically go ahead and then add it to the ECS instance that we're going to create. So this is useful, the image URI, which we will be going into later. So that's the Docker build and the push, super simple. And then you now get to the AWS prerequisites. So when you're working with AWS, there's a few things that you really need to do and kind of set up before you do anything really. You want to review your identity management to make sure that all of the users that you have set up have been correctly given the proper roles, and you set up the boundaries, because otherwise, you don't generally want to be using your root account and give it access to every little project that you do. So you want to be using something that is specific to that project, and also making sure that you have all the roles. In my case, I'm actually all I really care about is this AWS service role for ECS. This is a managed role that AWS will create for you when you're working with ECS, and you basically don't have to really do anything. You just need to make sure that that is there, and then you can basically go ahead with the IAM stuff. So that exists. Next, you just need to make sure that all of your security groups are properly defined. So we can basically get to that via C2. So security groups in AWS are something that allows incoming and outgoing connections and kind of controlling what happens. So by default, AWS denies access to everything. So in our case, we want everyone to be able to access port 3000 on our app. So we define an IP4 rule, custom TCP, port range 3000. Again, I'm not going into the specifics of these things because this is all very simple. And if you do get into AWS, you'll be doing these things in no time. But essentially, all you have to do is just create a new rule. For example, you can edit inbound rules, and that's it. It's all done via the UI. So there isn't really anything specific we need to cover here. It's just kind of the basics, just to make sure that we've done our part in here. So 3000 is open. That means any resource on AWS that has this security group applied to it will allow incoming connections on port 3000. So we have that covered. And then we need to make sure that there is a load balancer. Now you can also do this without a load balancer, but you need to assign a public IP to your resource. And since that resource is going to change all the time, you don't really want to be dealing with, kind of reattaching the IP over and over again. So what you do is you create a load balancer. Go in here in EC2. Once you create the load balancer, again, I don't create it here because it takes about 5 minutes for the load balancer to initialize and then come up. So you're not really running anything here, but it's essentially very simple. All you have to do is whether you want an application load balancer or a network load balancer or gateway load balancer. Here, in our case, we want an application load balancer because all we are concerned about is making sure that HTTP and HTTPS traffic comes through. So we create that load balancer, and then what we do is we apply the security group that we updated earlier. So
yeah.
guys, if you could mute.
You came for the key. Police better. Police better.
Rohim, yeah, can you mute?
Police area is
all right. So you're gonna create the security group, and then you basically assign the security group to your application load balancer. So now you have allowed the 3,000 to come through, and then you're just gonna add a listener. 3,000, and you're done. So you don't really need to do too much here. Hang on, I'm just gonna see if I can.
Leasing the rent agreement. I
can't mute, so I think I need to do that. Okay. So once you create the load balancer, you don't really need to then worry about it, because the thing with ECS is that all of the resources available are managed by ECS. You're just making sure that you have like the pieces in play before you go ahead and get to ECS, because if you remember, this is still in a way in the prerequisites. So now you have all of the pieces in play and ready. So you have reviewed IAM roles. The services for role for ECS exists. The security groups are created specifically for our application, which is 3,000. But if you're running like an HTTP application, it will be 80, and then if it's HTTPS on 443. There are also, predefined security groups that you can apply, for things like SSH, it will be 22 and so forth. So it's, again, nothing that you need to really worry too much about. And then you also now have the load balancer created. You can do a lot of these things while you're doing these ECS setup, but we're just going to do them earlier just so it's a little faster. But I'll show you where you can also do them while the setup is going through. So now what we do is set up the ECS cluster. This is where all of our resources are going to be maintained. So I'm going to go into ECS. And then I am going to go into the cluster. So I've already created a GapStar cluster. Right now, there's one service, which is the one I created. There's no CPU utilization and no memory utilization because there's nothing running on it. But I'm just going to show you how to do this here. You go into create cluster. And again, you just need to select the options available. There's a few things here that you need to really think about. Whether you want serverless, where AWS will be managing the server for you. But you don't even have a like a server to log into to SSH into. So this is where you only actually pay, only have to worry about the networking. Everything is managed for you. It handles the servers, handles logins, everything. So you can go, and that's the offering is called Fargate. So that is this option, or you can go for either Linux or Windows, where they assign an EC2 instance for you. And you can use that as the capacity provider. So generally, question is it going to be serverless, or are you going to manage your own server? Serverless is generally more, it's cheaper, because depending on how much utilization is happening, it's anywhere from 35 to 80% cheaper than EC2. But again, if your application has kind of peaks in or bursts in how much traffic it's dealing with, and you go over the allotted utilization, it's going to start becoming very expensive. So it can be up to 35 to 50% more expensive than EC2. So you need to understand your traffic before you make a choice here. But we're going to go with the Fargate because it's the easiest to work with. If you go to the next step, just give it a name, and when you create it, there's again nothing much here. So I created the GapStar cluster. And I have one service here. I'll go into that in detail, but this is how it looks like. So you have the cluster set up, and you're all good. So what's next? You're now going to have to work the task definition. So think of this as the wrapper around Docker, and think of this as a description of the type of compute that you want. So how this works is you go into task definitions. Again, I have my own one here. I'm just going to take one of the existing task definitions that I've created, and I'm going to create a new revision. So it gives you all the same options. Give it a name. Task role is basically to do with permission. So when this application is running inside Fargate, it assumes the permissions given to this role. So if you've given this role permission to say log to CloudWatch, then it can log to it. So that's why it's important to make sure that you've given the proper permissions. Then you select the networking mode here. If there are reasons that you may want to select each of them. I worked with all of them. Generally, though, if you're going with Fargate, you're just going to go with AWS VPC, which makes things the most easiest. If you're familiar with Docker, Docker has bridged networking, and that has implications on how services can talk to each other. So we're going to go with Fargate. So we're going to go with AWS VPC. And the capability is also Fargate. All of this you can really ignore, but here is all you really need to think about. So I've assigned 500 MB to my application. You can go up to quite a bit. I mean, 30 GB of RAM for your application, and up to 4 vCPUs. So those are pretty large compute resources that are available to you. So I just choose the smallest one that I need to go with. And then think of that as the compute available to you within this container, within this task. And then you start adding containers to this. So in my case, I just have one container, which is my application. But if you had more, like, if you had like multiple services, or if you had like a server and an application like Nginx and PHP, or it could be Apache, it could be something else that you want to add in here, you can then add those containers, and you just give it a name. And then you just have to make sure that you put in the URL that we got earlier. So this URL, and you create that link. So I'm just going to show you the one that I have set up already. So that's it. Now it knows, okay, I just need to get the image from the ECR store, that the repo that I created earlier. I open up port 3000, and I just make sure that it logs things to CloudWatch. So you can just set up the log configuration. That's it, and then it's pretty much done, because you don't need to worry about any of these things. But all of these, if you're working with Docker, it should be quite familiar. For example, you have mount points, you have volumes, you have the resource limits. You can also add Docker labels, and then you have things like the environment. This is the environment. So all of those things are, available in Docker. This is just kind of a UI that has been created around it, which makes it super simple. So again, name, repository URL, the port, and if you want CloudWatch, you just enable it right at the bottom. You don't even need to define any of this, because these things work within the container. So if you only have one within the task, so if you have only one container, it's just going to take up all the resources available to the task. And then when you create it, all it does is that it creates a task definition, which is versioned. So imagine that you created one version which is using up more memory, which uses up a different configuration, and then that stops working. All you have to do to revert is to simply update your task and switch back to a different version. So you can even set this up so that your app CI/CD automatically creates a revision for you every time you do a deploy. So then for you to revert, all you have to do is just update a menu item in the GUI on your service, and the application just becomes automatically reverted. You don't need to worry about anything. And that makes it super simple. So again, we've covered all of this. We're now going to go on to the next section, which is about services. Services make sure that whatever you basically define are deployed correctly. So here we have one service called Node app, which is going to make sure that Right now, the desired task for Node app is 0 and the running task is 0. Because when I went to sleep, I set everything to 0 so that I don't get billed for it. Now for the demo, I'm just going to enable it. I'm just going to go in here. I'm just going to update it. And I'll show you the create flow again completely. But while this is provisioning in the background, I'm just going to create 4 tasks. Skip to review, update service. Now, AWS is going to do its thing in the background while we're talking. So now it shows desired count is 4, pending is 0, and running is 0. Now it's basically bringing those services up. While it does that, we're just going to quickly go ahead and look at how what you need to do to create a service. So for you to create a service, you just go into create. And then again, you decide whether you want the launch type of Fargate, EC2 or external. You can also run your own infrastructure in here. ECS makes it easy, but generally Fargate or EC2 is how we go. You select the task definition, the one that we created earlier, if you remember, and then the version. So again, like I said, rolling back, simply switch on the different version, and then you're done. Select the cluster, give it some kind of name, service, and then you, again, these are kind of like, how you want it's kind of launch configuration information. And all of them have, a lot of information in there that kind of helps you decide what you want to go for. I'm just going to put 1 here. And here, let's say 10, right? So you can decide what kind of ratios you want when you're running this application. So if you have like 10 instances, whether you want, depending on how many requests are coming in, and depending on how healthy your application is serving those requests, the system can scale up or down. So for example, minimum healthy percentage provides a lower limit on the number of running tasks during a deployment, enabling you to deploy without additional cluster capacity. So the simplest way to think about this is if you have cluster capacity of 1 GB and your application takes up 100 MB, so you can have 10 tasks running at a time, right? So that's 10 into 100 is 1,000, and that's all 100% utilized. Now, say you want to deploy a new version, suddenly you don't have any memory to deploy the new version because your cluster capacity is only at 1,000 MB. So these values here allow you to kind of modify them a little bit so that if, depending on how much you're using, it can kind of intelligently make sure that new versions go through without overflowing the cluster's memory utilization. Then you basically can also, configure things like how deployments should be done. If you're familiar with things like canary deployment or blue-green deployment, these things enable you to deploy in a more structured way when you have a lot of services, so that you can roll back if there's a problem. For example, if you want to only start deploying everything over and then only 10% of traffic should go to the new version, that's how you, this is where you configure those things. And then you can also, set up a bunch of information on how they should be deployed. All of this isn't really useful to you when you start out, but the moment you start getting into things a little bit, all of this becomes a lot more valuable, because then it helps you make more intelligent decisions with your deployment architecture. So then you go on to the next step. I think I missed something. Okay. So here, just select the VPC and a couple of subnets that you want to deploy to, and then again, the security groups. But the important thing here is actually the load balancer type. Now, if you select none here, you're not going to be able to access the task inside here unless you assign a public IP. So there's an option to assign a public IP, or you can assign a load balancer here. So since we've already created one, we can just select the one that we created. So otherwise, we'd have to go create it and then come back. So that's why I created the load balancer earlier. And then you basically say which port it should be accessible on. Since our application is running on port 3000, we add that. And then we can also say on the internal port of your application is different from the load balancer port. Now, I already have something running on 3000. So because that's the application itself. I'm just going to set this to say 3001. And then all of this you can leave alone, and you can just set the health check path. If you remember in the code, I have a separate health check URL, this. So generally that's what you would put in there, because this is the URL that AWS will keep continuously polling to see whether your application is healthy. If your application returns that it is not healthy for whatever reason, then AWS is automatically going to remove that task and then redeploy a new one. So that's how it knows whether it's healthy, whether it is working okay, doesn't need to change. There's also more dynamic ways that it looks at figuring out whether a task is healthy or not. For example, if your API starts returning non-200 errors quite a bit, then AWS is going to automatically remove them. You can configure all of that on the load balancer side. So that's important because, for example, you don't want your task to be removed from AWS, from the service. If, for example, some malicious user is trying to get into your system and your system keeps throwing back a 403. So things are like that are what you want to kind of look out for and make sure that you kind of configure them correctly. Service mesh is its own thing, which is like its own lecture, I think. But essentially, it allows you to make sure that the communication between these services goes off without a hitch. There's a whole bunch of options that you can configure, and it goes with the AWS Route 53 DNS protocol. But it's its own thing, and again, you'll find where you need to use, like you won't really need to know about this right now, but the moment you do start looking into more advanced configurations, this will make a lot of sense and it makes a lot more easier for you. So then we basically just going to disable this. We go to the next. Again, if you want to set up auto scaling, right now you're handling say 1,000 requests per second or 1,000 requests per minute, and you know that it's going to go up to say 100,000. AWS can automatically handle it. There's really nothing that you have to do. You just say what kind of scaling that you want to set up, and then it will just go ahead and update the services at the time, depending on how much traffic is coming your way. So we're just going to disable that and then go to, and then you just review and then you create the service. I won't create it here because it's already done. And we go back here, and now we have a service with 4 desired tasks and 4 running tasks. And this is deployed. The gap star stock there's a typo, but the talk that we set up earlier, that we pushed earlier. So now it's deployed, and then again, we covered these things. So essentially, it's about making sure that everything is running okay. And once it's available, what you do is you just go into your load balancer. Because we didn't go for the public IP route and we set up the load balancer, we're just gonna hit the IP of the A record for the load balancer. So for the DNS name, otherwise generally you can also get your own domain and point it here. And if you have a DNS manager, you can just point it to this A record on your end, and it becomes much easier. Just gonna hit 3,000. And now your application is here. Now, what you really want to pay attention to is this, the process UID. So that's simply, I just generate a UID here for every instance that is running. So you're gonna see something similar to a round robin algorithm traffic allocation. So every time I reload this, you're going to get a different UID, and request left is not going to go down to 1 directly, because it keeps adding it to different tasks. So each task is actually getting the traffic. So different runs. So now at one point, one of these tasks is going to die, and we should get an error. So now 502 bad gateway. One of the tasks has died because that's how I had coded it. So now if you go here, running tasks, it's 3. 1 task is died. And if you look at stock tasks, you will see this deprovisioning and it's basically dying, and you'll see some, so the logs will be available on the CloudWatch side. But if you go in here, yeah, so the listening, I didn't put an exit statement, so it's basically only showing the example app listening bit. So that won't really show anything. So now what's it's doing is that it's creating a new task automatically for us, is provisioning it. And generally it takes about a minute or so. So it's now pending. And now, if you remember when I kept reloading, so there should be more errors coming because a lot of them were at request 1. But now suddenly you should see traffic where the request count has gone up to 5 again. So it's up. And now it's 5. So now it's basically giving traffic to the new task that came up. So I can basically, now this is another one that died, and the second one, and now we came back to the new one again. So now all the others should have died. There should only be one that is running currently. And they'll basically, yeah, so there's 4 stopped, and you have a lot more up. And there'll be provisioning more tasks as the tasks die, and then it'll keep coming up. So there's what happens is that it basically can self-heal, and depending on how many tasks and depending on how many bandwidth memory you've allocated, it can bring up tasks quite fast. So now it's brought up all 3 at once, and we're just going to wait until the provision. So generally, you're not going to have these tasks dying on you this often, because even if you have an error or something like that, the application, depending on how many instances you're running, can still continue. So we've had instances where we didn't even notice there was an outage with something else, because the AWS ECS orchestrator would just keep bringing up tasks, and we never noticed that the system was actually failing, just because as things fail, it will bring up more tasks. So again, system is up and self-heal, and I didn't have to do anything. It's all running automatically. So that's the orchestration part that I was talking to you about earlier. So here, with the app being deployed, it's essentially self-healing. You can do a lot of things here. So you can set up auto scaling. You can set it up so that, for example, at our company, our traffic pattern is fairly known. So we have more tasks ramping up during those specific times, and then they ramp down during, say, my morning, because that's pretty late in the night or early morning for Netherlands. So that way it helps us keep our costs down, because you're not really paying for compute that isn't being used. If you were running things on an EC2 instance, you'd be paying for that compute regardless of whether it's being used or not. So you need to look at the calculations to make sure that it makes sense for you to decide whether you're going to go with things like Fargate or EC2 or some other deployment configuration, so that it helps. Then you also have there are other alternatives like Lambda and cloud compute. Those will give you access to serverless, but the environment that you work in is very restricted. But with Docker and Docker and ECS, you basically can run anything you want. If you want to, say, do some video processing that happens only at midnight, say you're a big studio and that you just need to do video processing, say, for 6 hours every night, you just bring up a farm of Fargate instances and upload the videos to S3, and then point those the URLs to your Fargate instances so that they process it. They come up, process everything, and then in 6 hours you can just bring them down. Again, and it kind of comes down to the setup that you have. If you have CI/CD workflows, and you can just automate all of this with things like CDK, that's Amazon's offering, or CloudFormation, which is the older offering for DevOps, or things like Terraform, which will work across platforms on, say, Azure or Google or AWS, because a lot of these services, they will have similar offerings as well, managed container orchestration. So we'll be covering a little more of that later on. Again, here, the use cases here, if you listen to Gihan's lecture earlier, this is kind of ideal for service and microservice-based architectures, because it's all about services kind of communicating between each other. And this makes it so much easier because you can set things up with, say, something like a sidecar architecture with, say, Envoy, which manages all of the communication, and then AWS handles all of the orchestration and the containerization. This is not a tool that you get in on the basic level, because for you to use AWS ECS, there's generally kind of a heavy use case. If you were to just in actuality deploy that application that I did, something like Beanstalk or something like Lambda would be a better option, because there's a less kind of control, and it's a much simpler flow. But the advantage here with ECS is that the large ITs, there's also a lot more options there. So if you're working with large service meshes and things like that, it just gives you a lot more options that you can work with. And here, again, not a typo. It's good for when traffic patterns are understood. So you can go with Fargate and make sure that you bring up and down the services at the times that you need. And you have a very elastic capability capacity on your end. And it's, again, if traffic patterns are not understood, then again, you can kind of account for that by, say, having a set number of EC2 instances where the cost for you is known. For example, I can use EC2 here without paying anything for ECS, because, again, all your when you're using ECS, you're not actually paying for anything specific to ECS. You're just paying for all of the compute resources that are running underneath, whether it is Fargate or EC2 or the load balancers, whatever you use. So there's no actual charge on using ECS itself. And a big thing here is high availability. We've run applications that do up to 4,000 requests per second on very limited budgets. And all because you can basically set things up and you can scale things to the way that you want without too much trouble once you have that initial infrastructure in play. And some alternatives. So I think Clement brought this up in the morning. So Beanstalk, it's not something I had worked with, but essentially it's a good starting point if you want to keep things simpler. It doesn't give you as much control depending on what kind of architecture that you want to run. But if all your concern is with taking up an application that you have and package it and deploy it, along with the cloud-based load balancing, then Beanstalk is a good option. There is no environment limitation. I think they support a few things, Python, Ruby, PHP, Java, and it basically handles the whole CI/CD pipeline for you using all of the the AWS tools. Then you have Lambda, Cloud Functions here. This is a cloud native JavaScript, so you're kind of limited to, I think they have a couple of new environments. I think they do also now support not just Java, not just Node, but also other environments that they're adding there as I think some kind of packages, if I remember. But again, you're kind of constrained with what kind of workloads you can do, what kind of services you can do. And you also have to deal with things like cold start issues and other long running kind of compute issues, because these are kind of limited in what they can do. They're really good for what they are designed for, which is, if you need something that doesn't really use up resources if they're not running. So that's a good thing. AWS API gateways, another kind of backend API provider that you can use. You can connect it to all sorts of things like EventBridge and a whole bunch of other services, and essentially provide an API to external users with all of AWS's protections and all of the scaling abilities that you get. And for more simpler things, you have Honeycode, which is like a site builder, but also for apps and stuff. So it's it's the low code offering. For Kubernetes, providers, so like ECS, they have EKS. It's not as polished as ECS because it's still kind of not new, but I think ECS is definitely the more polished product. I think this might even be better on Google, but like, it is available though. And then the app framework again is kind of accelerated app and front-end development. It's not really for the deployment part, but you do get to kind of get from point A to point B to like the deploy point very quickly, because it's again kind of with the acceleration that they offer. So this is more about, you have a very large application, and or it could be an existing application, it could be new infra. How do you package it and then kind of make this more scalable, more sustainable with more visibility into it? So just make sure that you use ECS for the right thing. It's not always the best thing to start off with, but if you do have a bunch of infra in there, and then if you're looking to maybe save costs or maybe go for high availability or scalability, it's definitely a kind of a good service to explore. And I think that is, that's it. Do you guys have any questions? I think by the silence noted that everything was clear and understood. All right. Well, I mean, I talk about this topic quite a bit, pretty much with anyone who listen, and I also write about it. But if you guys do have any kind of questions later on, just hit me on Slack. I'm available. I think there's a chat message. Just to break the ice, yeah.
John, sorry to interrupt. So during this Q&A session, I would like to request everybody to turn on your cameras if possible, so we can interact also. Yes, John, you can carry on. Sorry.
Yeah. That's pretty much it. I mean, I'm available at office and on Slack. So if you have any questions, or if you guys need any help with moving some parts onto AWS, I've done quite a lot of work around it. So just hit me up, and I can see what you we'll see what we can do. And that's it. Thanks.
Okay. So yes. Thanks, John. Thank you very much for the session. So the session recording anyway will be available. So I'll be sharing it with everybody. And also, guys, I'll be sending you the feedback form. Please just give your feedback. So it will be very valuable for us for our future sessions. Okay, so thank you very much. Then have a lovely evening. Thanks, guys.
Thanks, guys.